All right, so this week, well, the past couple of weeks, we've been talking about our melts: mechanical, electrical, light, thermal, and sound energy. All the types of energies that we need to know about this year. And so this week, we're going to move on to focusing on light. Okay. Light is going to be energy that we can see. And let's go read more about light right now. Okay. What is light? If you think about our melts, light is just another form of energy, right? It's the energy that we can see. All right. Now let's focus on what that means to be able to see. The only reason that we see anything at all is because of light. Okay. Without light, we wouldn't see anything at all. It would be complete darkness without there being light. Okay. We only see anything as long as light energy is present. Now, when you think about something that's really dark, you might think about nighttime and you think to yourself, well, when I go outside at night, if I stand out there for a moment, I don't have any problem seeing. It's dark, but I'm able to look around and I'm still able to see things around outside even when it's nighttime. And that's because you still have sources of light outside even when the sun's gone down. We have street lights, we have porch lights, we have the light from the moon, we have light from the stars. Um, Even when all of the electricity goes out and there's a power outage around, you can probably still see outside at nighttime, even though it's really dark, because you still have the light from the moon and the stars. Okay. So that's still light coming in. The only way that you'd really get an understanding of what complete darkness is, complete absence of light, is if maybe you were to go into a closet and close yourself in that closet and put a towel down at the bottom of the door so no light can get in there. And that is complete lack of light. So that helps you to understand we need light to be able to see anything at all. And if we see something, and it's only because we have a source of light making that possible. All right. So let's talk next about how light behaves. All right. So whenever we're thinking about light, light behaves, it acts a certain way. Okay. And this is the most important thing first about light. We need to understand that light always travels in a straight line. The nature of light is that it always travels in a straight line, no matter where it's at, no matter where it's going. This is how a flashlight works. This is how a laser works. Okay. So light always travels in a straight line until it hits something. Okay. This is what we're going to be spending a lot of the next few days talking about. When light hits something, quite a few different things can happen based on the type of material that light is hitting. Okay. So when light strikes something, different things can happen based on the material that it strikes. It depends on what that material is made out of. Sometimes it can go through, sometimes it can be stopped, sometimes it will bounce back, and sometimes light can actually bend. Okay, so we're going to talk about the behavior of light over these next few days whenever it strikes something. But first and foremost, I want everybody to understand light always travels in a straight line until it hits something. Okay, so let's explore this a little bit more. The vocabulary that we need to focus on for this week, this isn't all of it, but these are our four main words I want us to understand. You're going to hear me, first of all, use these words: transmit and absorb. Transmit means that light goes through it. So as I'm talking, you're going to hear me say light goes through, light passes through, or I'm also going to say light is transmitted through. Okay? They all mean the same thing. Transmit is the science word for passing through something. So if you look at this window, light is being transmitted through that window. You're able to see completely through it. All right? Transmit. The next word, absorb. It means to stop and get taken in. All right? Think of a sponge, like a sponge you might use to wash dishes or something like that, or clean the floor. A sponge, what does it do to water? It soaks in, it takes in that water, right? Well, light can get absorbed by certain materials as well. So whenever we say that light is blocked by something, it's stopped by something, it absorbs by something, those are all meaning the same thing, all right? So there are things that can absorb light like dark colors do, okay? And when a lot of light is absorbed by materials, it can actually turn from light into heat. If you look at this picture here on the right side, this might be kind of familiar to something maybe your parents have told you in the past. We live in a part of the country where it gets really hot in the summertime. We've got a really bright light from the sun shining down. And you might have heard, don't wear dark colors like black in the summertime because you're going to get really hot. And that's because black absorbs lots of light and it converts it into heat. So in the summertime, we try not to wear a lot of really dark clothes like black so we don't get so hot. If you think about the color of vehicles that we see around our part of the country here, because we're really hot, What's probably the most popular color vehicle that you see around in cars and trucks? It's white, right? Most of the cars and trucks that you probably see around are white. We don't see a lot of dark black vehicles because in this part of the country, if you have a black vehicle, it tends to get hotter faster in the summertime, okay? And that's because dark colors like black absorb light. So those are the two words, transmit and absorb. Let's look at these bottom two down here. We're going to spend some time talking about these. Reflection and refraction. Reflection and refraction. Right away, you'll notice those two words sound very similar, and it's going to be very easy to get them confused because they both have to do with light. Okay, let's talk about the first one because that's probably familiar to you, right? Reflection. Reflection means that light is bouncing off of a surface, okay? So reflection is going to be something like a mirror, okay? Light is able to hit this mirror and then it bounces off to another direction, right? So I'm able to take this mirror, and if I hold it just the right way, you guys might be able to see my reflection right here, right? So that light is bouncing into the mirror and back off to my eyes, or your eyes right now. So that's going to be an example of reflection, okay? Refraction is going to be something different. Refraction means that light gets bent as it passes through something, okay? Light can actually bend and change direction just a little bit when it hits certain objects, when it hits certain materials, okay? And that's going to be refraction. You've seen examples of refraction all throughout your life. You just might not have known that you're looking at refraction when that happens, all right? So let's do a little bit of a demonstration real quick, and let's try to see what we can do as far as reflection and refraction here, okay? So for reflection and refraction, let's look first of all at a laser beam, right? So I've got my laser beam here. Actually, let me make this a little bit bigger. Okay, so I'm going to take my laser beam here, and I can use it because lasers give off light energy, right? So this is shooting light in a straight line. I'm going to take my mirror, and what do we say a mirror does to light? It reflects light. So I can make the beam of light coming out of here that travels in a straight line go in a different direction just by hitting my mirror with it, okay? So if I hit it straight on, I can make it reflect into different areas. Notice I'm keeping my laser steady. I'm not moving that. I'm only moving my mirror, right? So if you look over here behind me, where I'm kind of pointing to, you can see there's a little target sitting right up here. So I'm going to try to see if I can actually angle this laser just the right way so that I can make the light hit the target. So let's see if we can make this happen here, okay? Let me see. So you should see that kind of behind me. Let's see if we can do it. Mostly, okay, I'm not too bad at it. All right, so this is going to be an example of reflection. Light is actually hitting the shiny material and bouncing off in a different direction, all right? So that's going to be reflection, reflection. The next thing we're going to look at is refraction, okay? So if we take just a simple cup of water, we can make light bend, and you see this happen all the time, okay? One example it might be, you just kind of, if I just look right behind it here, I don't think you can see me. No, my eye doesn't look weird like that all the time. It's only because the light's passing through the air into this water here. So let me go on and take this pencil, not broken, perfectly fine pencil, I guarantee it. So when I put it in here, you'll notice down here on the bottom, it actually looks like it's bent in a certain spot, right? So right about right there, it looks like there's a bend or a break in the pencil, and it's actually looking lower than it really is. Now, when I take it out, my pencil's just fine. Nothing's really broken on it. But if I put it in there, that light, as it travels through the air, that light is hitting the water, which is a different material. And when it hits that different material, that light slows down and it actually bends just a little bit to make the image look like it's been broken, okay? So that's going to be our example of refraction. This can happen in water. This can happen through clear plastics or clear glass, okay? All right, so let's go on and move on to the next part. We're going to explore a little bit more with reflection and refraction here. The difference between these, we know that light travels in a straight line until it hits something, all right? If light strikes something that blocks it and it's shiny and it's smooth, like a mirror, then it can be reflected, and it can bounce off that object, like in this rear view mirror, the side view mirror of the car. Reflection's pretty simple. A lot of us look in the mirror every day before we come to school or before we go out somewhere. We know that a mirror reflects our image, right? Refraction here, if light strikes another material that will let it pass through, it can be refracted or bent as it passes through that material. So just like our pencil in the cup of water here looks slightly bent, or if I were to take a refraction block, this one's just a hard block of glass, and I were to look at something with it, it actually makes things bend a certain way. Now my face doesn't really look like that. I'm perfectly fine, normal, kind of. But if I were to hold this up, you can see that it makes things look like they're in a different spot, okay? And that's going to be refraction. Just like in this cup here, you can see the spoon looks like it's in a different spot. Here's some more examples of reflection, okay? Reflection, we know it's light bouncing off. You're going to keep hearing me say that definition over and over. Notice that it doesn't have to be a solid to reflect light, though. We can see examples of mirrors over here and something shiny like these sunglasses. But looking over here, look at the surface of the water. If water is smooth and shiny enough, if it's calm enough, you can see reflection off the surface of the water, like here and like down here. You can see the reflection of the lily pads and the flowers. Refraction. Again, here's some more examples of refraction going through water, going through glass. Refraction, again, this is bending of light as it passes from one medium into another. Medium is just the science word for materials or objects, all right? So you're going to hear me use those interchangeably. When light passes from one medium into another, it's passing from the air through this piece of glass, and as it goes through this piece of glass, it's going to make things look bent, okay? It's refracting them. This happens because light changes speed as it passes from one material to another. When light goes from the air, it's going one speed, and as soon as it passes into the water here, it slows down, and that's what causes the light to change direction and bend. Remember that it only makes things appear as if they are broken. No ducks or no humans were harmed when we made these pictures for refraction here. It only makes it look like it's bent. Okay, so let's review what we talked about. Light is energy that always travels in a straight line until it strikes something. Some of those materials will reflect light or refract light, okay? Remember, reflection is the bouncing back of the light off of an object, and refraction is actually bending of the light as it passes through an object or material. In your journal, you're going to be copying down this diagram here to break down those four main words that we talked about today. Make sure you put a little sun here in the middle as a source of light. And then over here, you're going to be writing these notes about reflection and refraction. And I want you to be sure to write these examples: a mirror, glass, shiny spoon, water, chrome foil. These are all things that reflect materials or reflect light, And then refraction down here is going to have some examples like water, glass, and even binoculars. A lot of tools that we use are going to be things that refract light. Binoculars, they bend light to make things that are far away look like they're up close. And even glasses, if you wear glasses, I wear contacts and glasses sometimes, these are meant to refract light so that it bends it just the right way that it lets you see clearly, okay? We're going to talk more about lenses later on. And also, one more thing that you're going to be putting in your journal today, this is part of a foldable. You're going to be drawing a little picture that shows reflection of light bouncing from the sun onto a material and bouncing off. And then refraction, you're going to draw the light coming from the sun and actually passing through this medium, this material, but bending and going a little bit of a different direction, okay?